machine learning team, and I'm mostly a UI developer. But as you will see, some of the stuff I'm showing today is also going towards less, let's say, web-based UI. My talk today is titled Efficient Data Science Workflows with Elasticsearch and Kibana, and the reason I say efficient is because not so much, of course, of only big data, but how can we also make our life a bit easier with what I mean with efficiency here. So, to start with you guys, who's considering yourself a data scientist? Is that something you do? Yeah? A few hands up? Great. Okay. So let's start out with talk about data science workflows in general, and there's like a myriad ways to define that. It depends on the use case. What we usually can pin it down to is something like you have to prepare your data, you analyze and work with your data, and then you want to maybe show off your data. So what I'm hinting at here is, and this will be what the talk is, because you could fill up a lot of talks with these individual steps. What I'm hinting at, what I want to talk about today, is mostly deployment. And how do you maybe escape the environment you're working in to present your data? And with what I mean with deployment, that's manifold, so let's dive into that a bit. I'm from the Austrian Alps, so I thought I need to come up with an example with snow. And it's quite fitting since yesterday. So imagine you're a skier and you like backcountry skiing maybe, so who's the data scientist and maybe a backcountry skier here, anyone around? So you have this task of saying, I have some outside snow conditions, and I want to find out if it's safe to go backcountry skiing. Usually what you do, if you're expert enough, you do a snow profile. If you're less of an expert, you might look up on the internet or on the radio, TV, your average warning levels, and based on that make a decision. So that's kind of your end goal of your analysis. Is it safe to go out there in the backcountry? If you're a professional, and that's what they do in the Austrian Alps a lot, is if you do the snow profile, not only out there in the snow, you then do a deep analysis of what's going on in these different layers of snow and how dangerous are they, or how tricky is the snow layers, and how likely are they to trigger avalanches. But that's not something you, like an end user, would want to do every day you go skiing, of course. So let's categorize this a bit. So I have my outside world, a diffuse complex system, and then I might have an expert system, but I need a certain knowledge or education to be able to make an analysis based on that. And then what maybe experts are able to create a layperson system, still considerate, but an end user skier might use to make a decision on whether they want to go into the backcountry. And if we transfer that to data science, we could say, that diffuse complex system is our source data. We have an expert system that's, for example, Jupyter Notebooks, Apache Studio, whatever your environmental data scientist works in. And then we have this task of either deploy, for example, your data, and also knowledge transfer. So what I consider this twofold. There's a technological aspect. You might want to break out of your maybe local Jupyter Notebook setup to somewhere where you can share your work. But you also have to think about that what you're working on you might understand it because you have the expert knowledge, but you have to do a knowledge transfer to make it understandable for other people. So that's about that. And now I'd like to just walk through, like, in the Elasticsearch and Kibana ecosystem, what are ways where we can help in that regard with a focus on deployment. The first thing I'd like to share is Eland, and that's our Python library that's on top of the Python client with a focus on data science. Usually, because that's the headline here, pip install Eland. And this has a few different ways it can help you. The first one is this is your go-to tool if you want to deploy third-party models in Elasticsearch. So what it does in the hood, it takes models, the supported ones, from that you would train outside Elasticsearch, and then it will be serialized and uploaded to Elasticsearch, where you can then use it as an inference model for different use cases. So this can either be models you train yourself, or you can also take some from Hugging Face, where you have a library of existing models. The second use case of Eland is that it has an API that's very similar to Pandas. So with the difference that under the hood, you're not having your data in Pandas locally, but you're actually querying Elasticsearch. So in this example, we're creating certain histograms out of your data, and you can see here that it looks similar. Where is it? We create the histogram here. We use matplotlib to chart it. Under the hood, you can see what I highlighted here, that on your local machine, it hardly uses any memory, because you use a Pandas-like API, but all your data and the analysis itself, the aggregations, are done in Elasticsearch. But it's abstracted away. You don't write any DSL or something like that. You're using an API that's similar to Pandas. And with that, you can do heavily customized stuff. So there might be a use case where you don't want to upload an existing model. And for that, we have what we call data frame analytics in Elasticsearch. That's for the 3 use cases: outlier detection, regression, and classification. A suite of tools that allows you to do the whole process within Elasticsearch. So that's when you might have already your data within Elasticsearch. You could use transforms maybe to create normalized documents, for example, out of logs, and you want to identify the attributes you want to analyze. So in that case, your data doesn't have to leave Elasticsearch. We provide a UI and API that allows you to do the training, the validation, the testing, and the deployment of the model within Elasticsearch. So here's some screenshots of the UI. You can pick the fields for analysis. You get some previews of the data distributions. And once you run this, it runs as a task within Elasticsearch. It will create an additional index and also some validation and testing data. And for that, we have an UI that allows you to evaluate your results with some standard tools. You get a confusion matrix, you get your RC curve, and you can explore the data. You could also do this in Discover, but there's also a dedicated results page that shows you your training data and your results data side by side. What's also a nice touch is that the analysis supports feature importance. So that allows you to see, based on your training, which fields influenced, for example, the inference values the most. So in this case, we're analyzing flight data. It's one of the example data sets of Kibana. And you can see that for example, the distance of what we try to predict here. We try to predict if a flight is delayed or not. And for example, we find out that the field, how far a flight is, distance miles, has a larger impact, for example, on the inference than, let's say, the origin country. Another screenshot of feature influence. So on the table you see kind of a heat map of the fields here that you see. This is an outlier analysis, and you see the influence of a field on the outlier score. On the right-hand side, you see a visualization that takes the data and applies the the training output and tells you if something is recognized as an outlier or not. So that's the evaluation part. And then you can kind of also manage your models. So this is similar to when once you've got something via Eland into Elasticsearch, you also have these models you train within Elasticsearch in your model management page, and you can deploy them then on an index, for example, to create an inference pipeline. So that's Eland and data frame analytics. That's how we support you with your costume models and the whole workflow of creating new ones within Elasticsearch. Next thing I'd like to talk about is a little collection of utilities called Jupyter to Kibana. The idea is that if you're a data scientist and you're more used to, and your natural habitat is more in Python, then it's a bit tricky to develop something for Kibana, like a JavaScript-based plugin or something like that. So in this case, what's interesting, so some of the stuff I'm showing here is at Elastic, we once or twice a year we have something that's called 1 week, where we can say we want to, so we break out of our usual working routine and we can say let's work on some experiments. And that's where when I sometimes try to contribute something that I can publish as for the community. So this is more or less a side project that's happened to be public. And the idea was, how can we better support data scientists that mostly live at home in Jupyter Notebooks, but they want to create custom visualization they can then render and show in Kibana. The trick here is that for some time Elasticsearch has an additional plugin for custom visualizations that's based on the Vega specification. So that's kind of the secret glue under the hood. We have Elasticsearch as our data store. On the one hand side, we have Kibana and our dashboards, and the Vega plugin that supports the Vega specification. On the other hand, we have our Python library, or in Eland on top. We can use that in Jupyter Notebooks, and then you could also write raw Vega specs, but it's way easier to use the Alter library. And that allows you to create Vega specifications you can then deploy to Kibana. So the trick is that Vega is a spec. That means you create data visualizations as code. It's not about the data you render within the visualization, but the specification, what the visualization is about, or what it's like, is defined in a specification. And Alter is the part in Python that allows you with an API to create this spec. So you could write the raw JSON to create such a visualization, but it's quite cumbersome. And the API, the library Alter, gives you, of course, better error reporting, for example, and a nicer way to develop these visualizations. To look at some examples and comparisons, let's see if we can make this work. These are really simple examples, so there's not a lot of going on in terms of analysis, but the idea is that how can I visualize these or create these visualizations and then bring them to Elasticsearch. So this first one is, I have a data frame, pandas data frame, and I create a matplotlib-based visualization. This renders a bitmap, and the problem is everything we do here to create it is based on Python, and it then renders the output. So in that case, I have no way of bringing this type of visualization into Kibana. Let's go down. I think here's the next one. So once I start using Alter, I have the benefit first. It's no longer a bitmap. It's an SVG. It's not in here, but it could also render tooltips and do some interactivity. And then, because we're now rendering this spec in the Jupyter Notebook, there's this little button here that says I can save it as an SVG, as a PNG, but also I can have a look at the spec. So that's now the spec I get for this single visualizations. Of course, the more complex it gets, also the more complex the JSON turns out to be. But that's the thing then we want to deploy to Kibana. So moving further down, we are now using still Altair to create something a bit more complex. Small multiples is what you call in data visualization when you have multiple charts of the same type showing different attributes, and that allows you to more quickly compare data attributes. And that's historically something Kibana has a little bit lack of support, so it's a nice way to create this in Jupyter, in a Jupyter notebook, and then deploy it to your Kibana dashboard. This one is then a bit more complex, and let's have a look at the source. So this is what comes out. It also, in this case, for rendering in the Jupyter notebook includes the data, but you don't want to. There's no joy in writing this JSON. So this is a nicer API to do this. So the last piece is then a helper that takes this specification and deploys it or uploads it to Elasticsearch or Kibana as a saved object of the type of a visualization. And the end result is, let's go back to the presentation here. So these are just the screenshots. The end result is, once I deploy it, I can render it in the dashboard, and it's not like in the first example, a bitmap. It uses the data from the cluster, and that means I can also apply the filters or queries I have, and it's no longer this one run of the data I did in the Jupyter notebook. So I can then play around with filters and say, oh, I'm only interested in ticket prices above 100 and below 1,000 here, or I can render some custom visualizations that are not possible out of the box in Kibana, like a violin chart on the right or some costume scatterplot metrics to analyze outliers. So now we talked about the way how to bring a visualization from Jupyter Notebooks to Kibana. The next thing is it like the other way around. You might ask why, but there are so many use cases for different kinds of stuff. So the next bit of the talk is about data science and static site generation. Static site generation, what is that about? You might more know it from the world of websites, where in comparison to, let's say, a WordPress website that has a database in the background, and every time a user comes to the website, let's not talk about caching, but in theory, user comes to the website, it renders the page, it queries at the database to get some information, and then displays it in your browser. Static site generation flips this around a bit, so there's a build process that upfront creates your whole website, and then you publish to a web server just your static files like HTML, JS, and so forth, but you don't have a live database in the background. There's some benefits. You have a much simpler live setup to maintain, and there's also less risk. For example, if your technology might get outdated at some point, but the statically generated site will more likely stay around to work. So the general workflow for creating something like this could be that you create some custom visualizations again in your Jupyter notebook, using again Altair. You get your data with the Python client, you create a Vega chart, you create the Vega spec, and then in this example, you could use a GitHub action that is basically the build process that takes these Vega specifications, puts it into an HTML template, and then finally creates an HTML page that you just upload to a static server, in this case a GitHub static site hosting. And you can see here again what I meant with this. When you think of deployment, you also have to think about knowledge transfer. So this is your expert system, you're doing the data analysis, you're creating your visualizations, but the end product is something that has a lot of annotations and explanations for something that is the target audience, for example, for your analysis. So that's really like handcrafted and but still can be quite automated. You could say combine this with GitHub Actions where every commit, for example, you run this daily and you refetch the data under the hood. You do the build again and you have an updated website. So that's for use cases where you don't have to, you don't want to, or you don't need to access the full source data, and you want to provide a curated experience for the end user. What popped up recently in that regard is Observable Framework. That it's really also a company, Observable. They take this whole approach and provide a developer experience to create these kind of statically generated sites. And you can see here on the left side, the whole workflow here is about first development and then publishing, and again, important bit here, the deploy. So as long as you work on it, you have a preview in your browser, you edit the files, and it's a very convenient user experience because they have live refresh and coding refresh in place and stuff like that. So you work on that stuff, and once you're done, you publish it. They also have the context of data loaders because, again, not every data scientist is a great, for example, JavaScript developer. So their concept of data loaders is that they provide a build system where you can create your data loaders in various languages. So you could use Python or R or some other languages to fetch your data and bring it in the shape that then is usable by your web application. So this summer we provided it's more or less a part of the official documentation now, which is an Elasticsearch data loader that provides some examples how to use Elasticsearch with Observable Framework. And related to that, what I showed with Eland and the pandas like API, under the hood is using DSL. With ESQL, since I think 8.15, there is an option to output the result as Apache error. And that's in the data science community a well-known and loved format because it's very efficient and it supports streaming. So when you run this, for example, right now it's just this URL option where you say format is error, and then you get back the error format that's reusable with a lot of libraries. And that's also where I come to the final example, where we talk about a bit more complex setup, where we use Elasticsearch and Observable Framework. We use ESQL to do like a first step of we take our really granular data, for example, all the logs we have, and ESQL is like a first pass and say we want to aggregate the data to a certain level we then need in our application later. We pass it as Apache arrow to Observable Framework, and then everything is still done in the browser. So the fun part is that just because it's called static generated sites doesn't mean it can still be interactive. So in the browser you would have then a WebAssembly based database that hosts your pre-aggregated data, and you can create this interactive interface, but it's no longer doing additional queries to an Elasticsearch cluster. So everything is now already in the client, and you can scrub and drill down these elements. So to recap, yeah, we showed Eland to deploy some models and its pandas-like API, data frame analytics with regression, classification, and outlier detection, Jupyter Kibana for the use case of deploying visualizations from Jupyter Notebooks to Kibana dashboards, and then statically generated websites based on a full manual approach or also using Elasticsearch with Observable Framework. There's one key QR code, and that's what the one. If you hit this one, this contains all the links to the utilities and stuff I shared in this presentation. And that's all. Thank you.